Hello all, this video is on comparison between Nextion and DWIN Touch HMI displays. Here we have a basic DWIN model and an enhanced Nextion model. The enhanced model is NX3224K028, which is 2.8 inch model, and resolution is 320 by 240 pixels. The touch panel is resistive, flash memory is 16 MB, and the RAM is 3584 bytes. And it has got additional RTC and the GPU extensions. To access this GPU pins, you need expansion board for buttons and buzzer and IO adapters. And it has got an SD card slot for downloading project, and the connection is TTL, RxTX and ground. The DWIN model we have for comparison is also 322 by 240, and the Nextion model is built on STM32 ARM Cortex IC, while DWIN is designed on their own T5L 8051 dual core chip. It has got 5 volt TTL logic pins and a buzzer on board for the DWIN display, and SD card slot is also there for downloading the project. While the Nextion model, the buzzer is missing, onboard buzzer is missing. To access the buzzer, you need external expansion board. The logic is TTL, RxTX 5 volt and ground, and it has got additional RTC facility. In DWIN, we have wide varieties of models, advanced models which support SCAN, MODBUS and RS232, and sizes up to 21.5 inch available for industry support with enclosures. So in DWIN, we have very wide range of models. In Nextion, the models are very limited, and maximum size is up to 10 inch only. Now let us start with Nextion. Let us prepare some background images to make the background images should match the resolution 320 by 240. A Nextion editor software is used for the easy design of drag and drop components and simple ASCII text based instructions. It has got some panes which has got components, and right side page component and attribute component. At the bottom there is event pane. Now let us open a new file and select the model NXX32240K028, and then the orientation of the display, let us select it as 90 degrees. This is very simple in case of Nextion, while in DWIN we have to use the configuration file. Now you can see the canvas 320 by 240 resolution on the Nextion editor. On the right hand side it shows it is space 0. On the bottom attribute pane, if you want, you can change the color by selecting the BCO attribute and change the color. So the background color of the background image, that is the canvas, changes. We have not yet added the images. If you want to add the image, you have to use the picture pane. First, to start with, you have to generate the font using the font generator. Select the size of the font and the type of font, and provide a name to your font file and click on generate. Store it as .zi file. This is a font file for the Nextion editor. You can generate multiple fonts also of different sizes and store it in the same project. All are .zi files, and ID is provided automatically by the Nextion editor. It is stored inside the project folder and automatically added to the project, and you can see at the left hand side bottom pane with ID 0 and 1 we have added 2 font files. In the same pane there is a picture tab. You click on that picture tab and then click the plus symbol and add the background images. We have got 2 background images. Add that background images and also some icons we have. Add that icons also using the same picture tab. the resolution of the background images should match the resolution of the model, which is 320 by 240. The icons will be of smaller sizes. Now to add an image to the page, select the page 0 on the bottom attribute, change STA attribute to image, and then against the PAC attribute, click on browse and select the first image. Same way, to add another page, click on plus symbol, page 1 is added. At the bottom attribute, change the STA attribute to image and click on pick and browse to the second image, select the second image. So we have page 0 and page 1 with background images. Now let us add a button to the first page, page 0, so that clicking on the button will take you to the page 2, that is navigation. Click on the button. Now the button ID is B0, that is the object name is T0, and click on the TXT text attribute and change it to next, and then click enter to confirm. Now the text changes on the screen. If you want, you can change the color, or if you want, you can add a small image to that button. And at the bottom pane, event pane, there are two events, touch press event and then touch release event. Select the touch release event, so that when you touch and release the button, this event will take over. Under this, you provide the instruction page space 1, so that on touching and releasing this button, it will take you to the next page. Same way, go to the second page, page 1, and place a button component. Now let us add image. For this, change the STA attribute to image, and at the bottom PAC attribute, click on browse and select the reverse arrow, that is a back arrow icon. Now the icon will appear over the button. Let us change the text attribute to plain. We do not want any text on that. Select space and then click on enter. Now under the event, touch release event, provide this instruction page space 0. Now click on save, and at the top there is a debug button. Click on debug. You will see the debugging screen. Now clicking on the next button, it will take you to the second page, and clicking on the back button, it will take you to the first page. This is very powerful and simple debug, and the instruction is a special thing to Nextion editor, which is not available in the DWIN. Now let us add some components to the page 0. First is the text component, which is object name is T0. Next one, let us add a number component, which is N0, and then a dual state button, which is BT0. This is not button, this is dual state button. The image changes according to the state. And then let us add two buttons at the bottom, which is B1 and B2. As already we have B0 to navigate at the bottom for the next screen, it is assigned B1 and B2. This object name is automatically assigned by the IDE, and you can select the components, and there is an align facility in this editor. You can align the bottom or to the same size, all the components to the same size using this align tools. Now let us click on the debug to go to the debug screen. Now we can provide instruction in the debug to change the value of the objects. First let us select the text object. Under the instruction, provide T0, that is the object name, dot parameter, that is a TXT text parameter, and the value is under the double quotes. Let us provide hello, it changes, the text changes. Same way for the next one, number, that is a N0 is the object name, dot VAL is the parameter, equal to provide an integer. It supports only integer math, no float math is allowed, only integer. The number changes. You can see on the debug screen the N0 value changes. So like this you can change the text of the b1 button, b1.txt parameter equal to the data, that is the value in double quotes. Now close the debug window. Now let us change the values of the components using the attributes. Select the first attribute, that is the t0 text, and change it to hello, txt to hello. And the second attribute n0 number, let us provide two buttons, to the left one button and the right one button, and then we change this button background to image, that is the up arrow and down arrow. Clicking on the up arrow and down arrow, the number n0 varies. Click on the b3 button, change the attribute sta to image, and against PAC click on browse and select the up arrow from the icons we added to the picture pane. And the txt attribute, let us provide space and enter. And the button B4, same way, select sta to image and click on browse, select the down arrow and the text attribute to space and then return. Next the BT0 button, dual stage button, click on sta, select the image, under PAC click on browse and select the first image, that is the red button, off button, and PAC to browse and select the on button, that is the icon. This is for dual state. And then against text attribute click on space and then enter, so that the text there is no text. Same way for the buttons at the bottom, change the text to on and off. Now click debug and then click on up and down arrow. Now it is not changing as we are not provided any instructions. So go back to the IDE and click on the up arrow, that is a green arrow. At the bottom there are two events, touch press and touch release. Select touch release event and then provide this instruction n0 dot val, val is the parameter, and then plus plus. So clicking on that button, the n0 value increments. Same way for the down arrow event, provide n0 dot val minus minus and then click on debug. Now if you click on the up arrow, the n0 value increments, and against the down arrow the value decreases. So this type of instruction is special to Nextion editor, it is not available in DWIN. And for the button BT dual state button, let us provide this instruction, if bt0.val has a value of 1, let us print capital A, otherwise print capital B. So just by printing the characters A and B, we can detect in the Arduino code, and accordingly we can operate the LED. That is the idea behind this. So clicking on the dual button, first it will provide a character A, again on clicking it will provide B. For the buttons B1 and B2, let us provide under the touch release event to print C and then D instructions, so that pressing on will send C and pressing on off will send D, and dual button it will send A and B. Finally, under file you select the TFT file output to select the output file generator. This is the .tft file which you have to copy to the SD card. Copy this file and then paste it under your SD card folder. SD card maximum support is only up to 16 GB. Now provide the power to the Nextion display. This is 5 volt and ground. Provide the supply. The default factory demo will run on the display. So this is the enhanced HMI display, Nextion display. The factory default is running. Switch off the power. Now plug in the SD card with the .tft file. There should not be any other files inside this SD card, only the .tft file. Now provide the power. It should the demo should load. If power supply is not proper, it will not load. So provide always 5 volt 1 ampere. Now the program is being downloaded, the demo program is being downloaded, and it is success. Remove this power and SD card and then provide the power back. Now you can see the demo you created on the screen. The up and down arrow increases and decreases the number, and then the button operates, and the next button navigates to the second page and to the previous page. So as per the program it works. Now let us connect it to Arduino and two LEDs, one LED at digital pin 7 and another LED connected to digital pin 8, and the RX is connected to TX and TX is connected to RX. Ground pin is made common, and this is the simple code. We define the digital pins first, and then under the void setup we define the serial.begin as 9600, which is the default baud rate of Nextion display. Under void loop we wait for the serial data, and if it is character A, we use the switch case statement. If it is A, we switch on the LED at 7. If it is B, we switch off the LED. If it is C, we switch on the LED at 8. If it is character D, we switch off the LED. The code is very simple. Remove the RX and TX wires as we are using hardware serial, and then upload the code. Now the code is uploaded, and touching on the display, the respective LEDs is switched on and off. So as per design, it is working. The Nextion display. Now let us see the DWIN display, the same project. For DWIN project, you have to prepare your background images using Paint, Inkscape or GIMP image editor. Unlike Nextion editor, this background images to be prepared previously. You have to provide the text space, and then the button space, and back and forward arrows, and other buttons and text. Previously you have to design using the image software, and then store it with the same resolution of the display, which we are using is 320 by 240. DGUS is the software for DWIN display projects. Open the DGUS software. Before that, you select the you keep ready the images prepared. We have two background images and some icons. This first background image to be named as 00. So this naming is very important in DWIN. The number should start from 0001 like that. Same way for icons also, rename all the icons to 0001 02 like that. So only the numbers, and the number should start from 0. This is very important in DWIN. And from the DWIN software, first you have to create the fonts, same as in Nextion. First thing is you have to create the font. Before that you select the resolution 320 by 240 and navigate to the project folder, and then click on OK. So the DGUS software will create some folders. Main folder is DWIN_set, which is automatically created by the software. Now you create font using the font generator. Click on the font generator from the welcome screen of the bottom. A separate window will open. Select a character which is a white character like W or M, and then adjust the X and Y axis, adjust that so that the character is visible clearly. Now click on create button. Now the font is being created. It will take some time. Compared to the Nextion editor, it will take more time. Once finished, it will create a .hzk file inside the folder from where you started the DGUS software. That is where the exe file is provided. You go to that folder, copy that file and paste it into the DWIN_set folder of your project. These folders are all created automatically by the DWIN software while you create the project. Now this font file is inside the DWIN_set folder. Now you have to create the background images. Go to setting, DGUS serial port, and there are some tools. The main tool is the ICL tool, and then the CFG tool. CFG tool will come back later. First is the ICL tool. click on that and then select the images. Navigate to the image background images where we have created 00 and 01, two background images. Select that image and then click on generate ICL. Now it will take you to the DWIN_set folder. Otherwise you have to navigate to that folder and store it as 32.icl. No other naming is allowed. It must be 32.icl. So the flash memory is 16 MB and the subspace, it is divided into 0 to 63 subspaces of each 256 KB. So within that range only you have to provide. So for ICL it is 32.icl. Same way, select the other icons using the ICL tool and then click on generate ICL. Now you can store it as 42.icl. Already we have used 32.icl. So total space is 0 to 63. Within that range only you have to provide. After that 32 you can either use 40 or 42. 42.icl for this icons and store it under DWIN_set folder. Next, the CFG edit, it is found inside the same ICL tool window. Click on that. There you can see the default baud rate is 115200, which is the default baud rate of the DWIN display, and then the ICL address you can see 32. Here you can change the backlights, sleep, touch sound on and off, and the touch for buzzer or music. And the main thing is touch sensitive variable changes updated. It must be auto, otherwise RxTX will not work. And then the display direction. For our model, the display direction default is vertical. Change it to 90 degrees. In Nextion display, it is very easy to change the display direction just by clicking on the window the direction. But in DWIN display, you have to edit the CFG edit file. And now after changing the display direction and then the touch sensitive variable changes to auto, now click on new CFG and store it under DWIN_set folder as name T5LCFG. .cfg is automatically provided. No other name is allowed. T5LCFG in capitals. Store that. Now go to the DGUS editor. Click on the plus symbol to add the pictures. After preparing the ICL images, ICL file, now you add these images just by same way as the Nextion editor. Click on the plus symbol and add the images, background images. We have only two images, 0 and 1. 0 and 1. The note the namings 0 and then 1. Now let us add the objects. At the top of the DGUS software, you can see the tools menu. Here you can see object for the tools like icon show, text show, graph, touch, edit tool, and then settings. And the Nextion, there is a toolbox and limited number of components, but they are powerful. In DWIN, the tool objects are a huge number of objects, and it is also very powerful. Now select text show under text show, text display, and click a box over the area where you want to display the text. Now you have to provide the VP address. It is very main thing in DWIN. It is just like object name in Nextion. Out of 128 KB RAM space, 0x1000 to FFFF, you can provide the VP address. Now we can provide a VP address as 1000, and if you want you can change the color. And then the mode is 0x02, which is GBK. Under the drop down there are other modes also. Either you can select 0x02 or 0x05, which is Unicode. For English, only these two type of modes. We will select 0x02, and then the alignment center or left, and then the text length is, let us select it as 20 bytes, and font ID is 0. Only one font we have created, so that font we will select. And X and Y axis, Y to be the double the value of X, and the default value let us provide as the text hello. This is the default value. When you switch on the display, it will show hello, and then click on save. Now click on show and then click preview from first. A separate window will open. This is only a preview window where you can see the text. That is the default text. Double click to close. This is not a debug. In Nextion editor, there is straight away debug. There is no preview, it is straight away debug. And under debug you can use the instructions to change the values, there is a parameters of the object. This is very powerful. In Nextion, in DGUS editor, that instructions is missing, but debug is there, which is also powerful. Now let us add from under text show a data variable display against the place where you want to display the number. You have to provide a VP address. Everything works on VP address, so let us provide a VP address 1200. All VP address you have to note it down in a paper, so that while coding it will help. And the color of the display you can change, and the font size, font ID is 0, and adjustment is alignment you can select, and variable type is integer 2 bytes. Now for up and down arrow you have to provide the adjustment type, that is the increment, plus minus increment. For that, click from under the touch, click on plus minus increment adjustment tool and draw a box against the up arrow. Provide a VP which should be same as that of the data variable, as we are going to change the data variable by clicking on the arrow. The VP address should be same, that is 1200. And then the adjustment type, there is integer, and the adjustment type is plus, over limit operation is cycle, step length is 1, and lower limit and upper limit you can provide the lower limit and upper limit 0 and 99. If you want button effect, you can provide a button effect by clicking on the set and clicking a separate image, so that while clicking the button it will show the button effect. Copy this plus minus increment adjustment button and place it onto the down arrow. Here the VP address is same 1200, only thing you have to change is the adjustment method to minus, as it is decrement. Now save and then click on show preview from first. Here you can see from the preview, you click on the down arrow and up arrow, the value changes from the limit what you are given, 0 to 99. Double click to close the preview. In Nextion editor, we achieved this increment decrement using the instruction for under the touch release event. For a touch release event of up arrow, we provided n0.val++, and for the down arrow, we provided n0.val-. So by instructions, we achieved this. In DWIN, it is totally different. Now let us see the page navigation. For page navigation under the DWIN, under the first page, page 0, there is a right arrow. Click on touch and basic touch, draw a box over that, and to the right hand side attributes, select the set page switching and select the image, that is a page 1. Select the page 1 and go to the page 1. There is no image we created previously, so let us use the variable icon display, icon show, variable icon display, and provide a VP. Always provide a VP for any object, and select the icon file as 42.icl, as we have created previously for icons, 42.icl, and under minimum select 0 and select the icon ID, and maximum is 1, so we are varying only one icon, so select the same icon ID. So the icon is not changing, only the left arrow is there, so we are not changing the icon ID to be same. Now click on save. For basic touch, you have to add the basic touch over this icon, and click on set and then select the page 0. So on clicking this button, it will go to page 0. Save, click on save, and then under show, click on preview. You can see the preview window. Click on the right arrow and the back arrow to switch the pages. This is how page switching is achieved. In Nextion editor, we use the instructions under the button touch release event. We provide page 0 and then page 1 instruction for navigation, but here we use directly the basic touch effect. Next is the dual state button. In Nextion editor, we use the dual state button. Under the touch release event, we provided the instruction to print C and D while touching the dual state button, it changes and prints C and D. But in DWIN display, we will be using the icon show variable icon display and provide a VP address 1400. Note down this VP address. This is important and to be used in our Arduino code. And under icon file, select 42.icl, and then the minimum is 0, and select the icon ID as the off power button, and the maximum is 1, as we are using one icon only. 0 and 1, 2 icon, and then select the icon ID and select the green power button. So the icon changes from red to green on clicking on that. Now we have to provide a touch over this, touch effect over that. From touch, you select plus minus incremental adjustment and draw a box over that variable icon. And VP to be same, it is very important, it is 1400, and you have to click click the data uploading if you want the output at the RxTX pins. And then the type is integer, adjustment type is plus, and operation should be cycle. As it repeats, it should be cycle. Step length is 1, lower limit is 0, and upper limit is 1, as you are changing only one icon from 0 to 1. And it is disposable operation. And then click on save, and then from show preview, you can see the preview. Clicking on the button, it changes, icon changes. It's just like the dual state button as we did in the Nextion editor. So using the variable icon display, we achieve this dual state button. And finally, the on off button configuration. In Nextion editor, we use the touch release event to print character C, and then for off button we print character alphabet D. That is in Nextion editor. But in DWIN, we'll be using touch return key code. That is similar to that event. We use the return key code, but it outputs only hex value. Now enable data uploading to upload the data onto the RxTX pins. And if you want button effect, you can click on set and select any image, so that when you click the button, there will be an effect, touch effect. And the key value, provide any key value. Let us give it as 0x01, but it is hex value, no text is allowed. And VP address is the main thing. Let us select the VP address as 1600. Note down this VP address, that is required for while coding. Copy this and paste it onto the off button. Here the key value only will change. Let us provide a key value as 0x02, and VP address is same, 1600 integer. Now click on save, and then go to show and preview window. Now click that window, click that button, on and off button. You can see the button effect as you provided button effect image. While clicking the button, it shows some effect, clicking effect, but that is default in Nextion. You have to create in DWIN. Finally, click on generate to generate the system bin files. It will be generated into your project. In your project, you can see many folders. The DWIN_set folder is the main folder that should be copied, as the full folder should be copied to the SD card. In Nextion editor, we copied only the TFT file, TFT output file, .tft file. But in DWIN, you have to copy the complete DWIN_set folder to the SD card. SD card supported is maximum is only up to 16 GB, and you have to format it to 4096 FAT format. And this is the DWIN basic display we have for this demo, 320 by 240 resolution. At the left hand side, you can see the RxTX pins and the supply pins 5 volt and ground. Now plug in the SD card with the DWIN_set folder, and then provide the power 5 volt and ground. You can see a blue screen showing all the files being loaded. There is a SD card process is shown in the blue screen. On the top, you can see T5L1 DGS2 on the version, and then the downloaded files. The .hzk font file will take some time for downloading. And finally, remove the power and then remove the SD card. Provide the power back. Now you can see the project on screen. The hello is displayed, the text is displayed, and then the touch effect, you can see the up and down arrow. Now you can hear the beat buzzes sound. It is not in Nextion. It is in DWIN. There is a buzzer provided. At the onboard there is a buzzer. In Nextion you have to add a separate adapter. This is the comparison between the two displays. The right hand side is the Nextion display and the left hand side is the DWIN display. Both the displays are smooth, both are resistive displays. The only thing is in Nextion the color capability is bit high and the brightness is slightly more. In DWIN display it is normal, but the touch effect is similar only. It is resistive touch. If it is capacitive touch, it will be much smoother. The brightness is slightly more in Nextion display, but for that both the displays are same. The response is also quick in both the displays. For debugging the DWIN display, we require a USB to TTL device like this. The debug is very powerful in DWIN. Let us see the debug. Connect the USB to TTL, RX to TX, TX to RX, and then ground to ground. Plug in the USB to TTL to your USB port. In Nextion editor, we do not require this USB to TTL for debug, but for DWIN it is a must. Now click on show and then click the debug button. A separate window will open. At the bottom you can see the serial port that is allotted to the USB to TTL. The baud rate is 115200, which is default. Click on open the port and then click write VP. Now provide the VP address. That is, we want to write some text to this location where the VP is 1000. So provide the VP as 1000, and under the data to send you have to send only hex value. So you need help of string to hex online website. You provide the string. Suppose you want to display DWIN, provide the string and then get the hex value and paste that hex value onto the data to send and click on send order. Now the data is transmitted to the DWIN display, but the previous display was hello, and we are overwriting this new string, so there is a confusion. Now first you have to send space, which is 0x20 is the hex code for space. So repeatedly for erasing 10 characters you send 10 bytes of data 0x20 202020, and then click on send order. Now you can see the display is erased. That is the text area is erased. Now if you want to display new string, provide the string to the string to hex website and get the hex data, paste it onto the player data area and then click on send order. The new text is displayed. So this may be slightly weird, but this is the way it works in DWIN display. Displaying text is only through hex. You need the help of string to hex, but in Nextion editor it is very simple and powerful. Just use the instruction and then use the txt variable and provide the data under double quotes. It will display. But in DWIN you have to use hex. This may be a disadvantage, but this is how it works in DWIN. Now let us see the debug for the numbers. That is a up and down arrow. The VP address is 1200. So click on read VP for this. So we are going to read from the DWIN display. Provide the VP 1200 and touch on from the display and up arrow and put it as 5. Value is 5 and click on read. The value you can see in hex. If it is 10, it will show it as 0A, which is in hex. So everything works in hex in DWIN display. For the dual state button, you have to enable the data uploading and then note down the VP address, which is 1400. Now click on read VP and provide the 1400 VP address and click on send order. So the dual state button, if you touch on first time, if you touch on that, it will show 00. Second time it will show 01. Same way the on and off button we have used to send a return key code 01 and 02. It is displayed. So same we can see using this SSCOM serial software. Open the SSCOM serial software with the same setup, USB to TTL. Click on open the COM port and if you touch on the dual state button, it will show some hex code starting from 5A5. Read that hex code, note down that hex code. It will be very useful while writing the Arduino code. While clicking on and off also, it generates some hex code. Note down all the hex code, hex arrays, which starts from 5A5, including the VP address also. It is seen there, 14001600. It is very useful for writing the Arduino code. This is the connection with the DWIN display with the Arduino. We have at the pin 7, digital pin 7 and 8 separate LEDs connected, and this is the Arduino code. We use the software serial and define the pins and start the software serial with baud rate 115200. 115200 is the default baud rate of DWIN, while in Nextion it is 9600. Under the while loop, we check for the myserial.available data, and you collect the data to the array. The data is like 5A0506A31400, which is the VP, which is located at index 4. We check for that 14 VP and then switch on the red LED, and check for 16 VP and switch on the on and off the green LED. Compare this to Nextion code. It is very simple by checking the characters we displayed using the touch button. So upload the code and then test the program. It is working fine. The red and green LEDs are switched. Thank you for watching.